Hello, my name is Simon and welcome to another video in the Big O Notation series. And today we'll be talking about the O(n) squared, which is the quadratic time complexity. In the previous video, we talked about the linear time complexity, which is the O of n, where the input size is directly proportional to the runtime. In this video, we want to talk about the quadratic time complexity, which is the O(n) squared. So what is O(n) squared in Big O notation? O(n) squares represent the time complexity of an algorithm that has a quadratic growth rate with respect to the input size, meaning the algorithm execution time will increase quadratically as the input size. So basically, an algorithm that is labeled as O(n) squared is going to square the size of the input. So you can look at what I have here, right? So supposing we have an input which is 2, right? We have an array that has 2 items. So the growth rate is going to be 2 multiplied by 2, which is 4. What if the input is 4? The growth rate will be 4 times 4, and it's going to be 16 in total. So guys, you can look at this example, right? For every position here, run through the list again. So at this position, right, it's going to run through this list, which is the whole list itself. So same thing apply to this position. You're going to go through the list again. At this position also, it's going to go through the list, the general list again. And at this also, it does the same thing. So that is why it is called what? N squared. So the input size will grow into X. Okay, let us look at some code examples so that we'll get a more better understanding. So let us look at a code example. So you can see I'm currently on my VS Code and I've created a file, a big O(n) square quadratic time. So I'm going to define a function and I'll call it count none. And this function is going to take a list. Okay, so in this function, I want to get the length first. So I'm going to send the length to the length of the list. Okay, so the next thing I want to do is to create a loop. So I'm going to do for I in range, of the length. Okay, so basically this is going to be like a loop in a loop. So there's going to be another loop for j in range of length of the length. Okay, so I want to print out, let me just put results I and j. Okay, so let me invoke this function so that we'll see what is going on. Alright, so I'm going to invoke this function, but I need to create my list. So let me just pass in some random numbers. Okay, so I'm going to invoke this function and pass in the list. Okay, so I'm going to run this function and let us see what we get. Let me close this. Okay guys, so if you look at my console, you will notice that for every position of 0, right? For every position of 0, this part of the code will run. And for every position of 1, which is by the right side, this part of the code will run. So it's 2x the size of the input. So it's going to continue until it gets to that length. So it's continuing in that fashion until it gets to the end of the loop. Okay, so you can see that too. For every 2, right, this part of the code will run for every at I is equals to 3, right? It's going to run that loop again. So it continues in that fashion. So this is a clear example of O n squared. All right. So let us look at the big O sheet. So if you look at this, right, you will see that the more the input size, the more it grows in n raised to power 2. Okay, so this is like the opposite of O log n, right? This is the opposite of O log n. So it squared the input size. So the takeaway here is at every input size, you're going to have the input size multiplied by the input size. So you can see it grows and it's in the horrible state. So guys, the final takeaway is at every input size, the growth rate is multiplied by 2. So thank you very much for watching, and in the next video we're going to cover the n log n. Thank you very much for watching. If this is your first time of watching this video, please ensure you like and subscribe. I'll see you in the next video.